I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll just discuss few questions based on geometric probability. We are going to consider area related questions in this particular video. So in geometric probability, probability involves geometric measures like length or area. So here you see a couple of figures. We will be interested in finding the probability of picking a point in the shaded area, may be read in the given figures. So based on this, I have designed few questions. The very first one here is: an archer aims at the target that is 100 centimeter in diameter with two smaller circles as shown in the figure. Radius of green and red circles is 20 and 40 centimeters respectively. Find the probability that the archer will hit the red circle, red region. Find the probability that the archer will hit the green region. So basically, red circle means the red region. So you can actually pause and answer this question. So as you can see in this, we need to figure out what is the area of the red circle and what is the total area of the bigger circle. Probability is the ratio of these two, right? So for question number 1a, basically probability of hitting the red circle will basically be area of the red circle, which is pi r square, over the area of the bigger circle, which is I'm writing here as pi capital R square. Now once you figure out the radius, you can find the ratio and get the answer, right? Similarly, you can work for part B also, where the green region is difference in the area of yellow and red, right? So that will come here and you can answer the question. So I hope you're getting the sense of it, right? Now the next question here is based on a triangle, equilateral triangle inscribed within a circle. The question is: an equilateral triangle with side lengths of 6 square root 2 centimeters is inscribed in the circle of diameter 12 centimeters. Find the probability that the point on the circle chosen at random would lie in the red shaded area of the circle, which is basically the triangle. Perfect. So now what I have done here is that in the playlist we have many questions related to how do we find area of different shapes, right? Even examples where the triangle is inscribed within a circle. The triangle could be isosceles, triangle could be equilateral, so those can help you in finding the area and the ratio of area of this triangle over that of the circle gives you the answer. Getting the point, right? Here is another type of question where we have a rectangle with a circle inside. The question is: a circle with radius of r is shown in the rectangle whose dimensions are r plus 1 by 2r. Write a general expression for the probability p, where x is equal to r, that the point in the rectangle chosen at random would lie in the red shaded area of the circle, right? So that is the ratio of the two areas, but you have to write an expression. Part B is: use your expression to calculate the probability if r is equal to 21 and assume pi as 22 by 7. Well, pi value is 22 by 7 approximately. It is as good as 3.14, right? But with the values chosen, you will find that it can be very easily done without using calculator. So that's the whole idea. Perfect. Many times when calculator is not allowed and you are using pi in the calculations, it is a good idea to select this value of pi, 22 by 7. It helps because the other values are related to easier calculations when you consider 22 by 7 as the value of pi. Part C is use the above result to find the probability that the point chosen lies in the blue shaded region. That means 1 minus the probability which you calculated in B, right? So if you calculate this probability as, let's say, P, let me call this as PR, right? Then this will be 1 minus PR, right? So that is how you could calculate this probability. Not a problem, right? Well, the next question here is, a triangle with angle at the center of 80 degrees is shown in the circle of diameter 12 centimeters. Find the probability that the point on the circle chosen at random would lie in the blue shaded region of the circle. So basically, you have to find the area of this triangle where this angle is given to you as 80 degrees. Right? You're also given the radius, correct? So you know that area of triangle area, let me see, is half of r square sine theta, right? So that helps you to calculate the area. And the circle area, you know, is pi r square, not a big deal. So you know these formulae, find the ratio and get your answer. Perfect. Now the whole idea here is that whenever we are finding geometric probabilities, we're basically interested in finding the ratio of areas. And therefore, it's a good idea to look into many questions where area calculation is primary, right? So for that, in the playlist, I have attached many videos where we are focusing on how do we calculate the area. Now, area of triangle could be calculated using Heron's formula also. You get the idea, right? So those are there in the playlist. Well, in case you want to learn from me, you can always send an email on the address given. Now, here is the last question, very interesting, which says, an isosceles triangle with integer side lengths has a perimeter of 32 centimeters. What is the probability that the area of the triangle is exactly 48 square centimeters? So that's a general question here. So with that, we end the set of questions for you. I'll provide you their solutions in separate videos, which will be included in this particular playlist. For the time being, what you can do is look into these questions, answer them, and post your solutions. I hope that helps. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.